Today we will discuss SI derived units. Actually, SI derived units are of SI derived units are of actually these are derived quantities. I told you in the previous lecture that derived quantities are those quantities which can be expressed in fundamental quantities. For example, density is mass upon volume, and volume is again length into length into length, length into height. So units of those are also the SI base units. So we can define simply, I can tell you, we can define simply SI derived unit. What is the SI derived unit? I can say SI derived unit is the unit which can be expressed in SI base units. SI derived unit is the unit which can be expressed in SI base units. And what is the SI common unit? SI common unit is actually SI common unit is that unit which is actually SI derived unit. SI derived unit, but not in SI base units. For example, if I simply define, I suppose volt SI common unit is joule per coulomb. Volt is joule per coulomb. It's not SI base units, but this is the common unit for the volt, joule per coulomb. When you write SI derived unit or SI common, SI derived, actually this is also SI derived common unit. What is the SI derived unit and what is the SI derived common unit? When you derive SI common unit or SI unit, when the units are multiplied, either you should leave a space for one character or you should put a dot if you are writing with the hand. So it is better to put a dot, and the units should be expressed as far as possible in exponents. For example, although meter per second, if you write in this way, this is correct, but this must be incorrect and you should write meter per second in this way. So actually all the exponent notations are used here. SI derived units follow the laws of exponents. Laws of exponents means when the same units are multiplied, their powers will be added. When they divide, their powers may be subtracted. For example, if you write here kilogram cube into kg, this will be kilogram power 4. Or meter square into meter cube will be meter power 5. Or if you have meter cube upon meter square, this will be just meter power 3 minus 2 or meter. So the laws of exponents are always followed. First, now see how we can see the units of how we can have the those SI base units which are very much common. You should remember those common units actually and see how we can derive those units. I'll make a table over here and also see. First I will recommend you should remember the SI common unit and how we'll be deriving some units. First, for example, how you derive force, unit of force. A unit of force is, you can have equation F is equal to ma. So unit of force is mass is in kg, acceleration is meter per second square. So this is Newton. I will write those SI common units. You have to remember here one by one. First, you have to remember that Newton is equal to kg meters per second square. You have to remember. Then it's the joule. Now joule is the unit of work or energy. Now I define work as simply FD, or is the force and displacement, product of force and displacement when they are in the same direction. So force is in Newton and displacement in meter, and its unit is joule. So I will say joule is equal to Newton into meter. Now further, if you want to for example, you want to have the SI base unit, now you can carry on further. For Newton is suppose it's kilogram meters per second square into meter. So this comes out to be kilogram meter square S power minus 2 in that way. you can always have the base SI, but you have to remember this. You cannot remember these units for the joule. Very difficult. You have to remember that just joule is the Newton into meter. Then Newton, you already remember it's kilogram meter per second square. So now you can change joule in SI base units very easily. Then it's the unit of power. Power we define as work upon time. The work upon time. So work upon time is, suppose work is in joule upon second. So and unit of power is watt. So I can say watt is equal to joule per second. If I want to change watt in SI base units, I can now change very easily. I can have joule per second. Joule is again Newton into meter and per second. Again, I remember the joule is Newton into meter. Then Newton is again kilogram meter per second square. So kilogram meter per second square into meter s power minus 1. So this will be kilogram meter square s power minus 3. So these are the SI base units of watt. So we have to remember these common units: Newton, kilogram meter per second square, joule, Newton into meter, watt, joule per second. Then for example, there's a unit of pressure. Now pressure is force upon area. So I will say pressure, its unit is Pascal. Its common unit is Newton upon meter square or Newton per meter square, m power minus 2. So I will write Pascal, P capital A small is n m power minus 2. Then there is the Coulomb. Now you know actually Q is equal to IT. From the equation, Q is physical quantity, I is ampere into second. So Coulomb is equal to ampere into second. Now this is not a common SI unit, but you should remember, because this can be expressed in SI base unit. This is not a common SI base unit, but common it's also used, you can use it. You have to remember this because it will be very useful for this one. Then there is the volt. We define volt as the work done upon charge. Work done upon charge, and work done unit is joule upon charge is coulomb. So I can say volt is equal to joule per coulomb. So volt is equal to joule per coulomb. And if I want to convert this, suppose joule, already joule is Newton into meter, coulomb is ampere into second power minus 1. Again Newton is kg meter per second square into meter, ampere power minus 1, s power minus 1. So this will be kg m square s power minus 3 and a power minus 1. The sequence doesn't matter. A can come here because these are just multiplying vectors. Multiplying units are kilogram meter square s power minus 3 a power minus 1. But you have to remember joule per coulomb. You cannot remember the SI units of joule volt of this one. You have to remember the volt is joule per coulomb. Then there's actually resistance. R is equal to V upon I. Its ohm will be equal to volt per ampere. So I have to remember the ohm is equal to volt per ampere. Then I can change this in SI base unit. Volt is just this one. Volt is this one. If you do not remember, you can directly calculate from this one. So suppose if I can say ohm is volt per ampere, then volt is actually joule per coulomb from this list. You have to rely on this list. Volt is joule per coulomb per ampere. Then joule is Newton into meter, and coulomb is ampere into second power minus 1 into ampere power minus 1. Newton is again in kilogram meters per second square, m a power minus 1, s power minus 1, a power minus 1. So although we have done this with kilograms, just simply I have to just be kilogram meter square s power minus 3 a power minus 2 will be the SI base units of the ohm. Similarly, there is the frequency, its unit is hertz, it will be per second. So you can always convert any unit in SI base unit just by remembering these 7 common things. Newton is the multiplication of kilogram meter per second square, joule is Newton into meter, watt is joule per second, Pascal is Newton per meter square, coulomb is ampere into second, volt is joule per coulomb, ohm is this one, ohm is volt per ampere, hertz is per second. For example, if you want to calculate something, suppose for example, what are the SI base units of Pascal? It's Newton per meter square, Newton is, again, you can see from this program, meter per second square n power minus 2. So this will be kilogram m power minus 1 s power minus 2. These are the SI base units of the Pascal. So by remembering these things, you can always have the SI base units calculation very easy. But if these are not involved, for example, in the density. Density is what? Mass upon volume. So I can calculate very easily. Mass, unit of mass is kg, volume is meter power 3, so it's kilogram m power minus 3. Similarly, for example, momentum. Momentum is mass into velocity. So mass is kg and velocity will be, of course, meters per second. So it's kilogram into meters per second. So in that way, we can always simplify these situations by remembering just these seven common units.